let's talk about parallel and perpendicular lines. So first thing we need to remember is the equation of a line. Okay, first thing is the equation of a line. And that is y equals mx plus c. That's the one we're using, right? This is our equation of a line. M is the gradient. Okay. C is the y-intercept. Right, so that means if here's my x and y axes and I have this line here. Okay, so the gradient is like the steepness of it. So if I go up and over, let's say I'm going up 1 and over 2, right? So our gradient would be 1 over 2, because going up by 1, our y value goes on top, we go up by 1, across by 2, right? So that's gradient, okay? Y-intercept is this point right here, where it crosses over the y-axis, okay? So we've got our equation of a line, we know our m value, right? The x value and the y value, those are like pieces of a point of a coordinate, right? So we've got gradient. Now let's talk about parallel lines. Parallel lines. So if we have two lines that are parallel, let's imagine these are perfectly straight and they're parallel. That means that, so they're both going to have an equation, y equals mx plus c, right? They're both going to have an equation like that. So, so let's say this is the first line and this is the second line. Okay, they're both going to have an equation like that. Because they're parallel, these two m values are going to be the same. Okay? Parallel means two lines have the same gradient. Okay, that one's straightforward. So if I gave you a question and I gave you two lines, I said y equals x plus 5 and y equals 2x minus 4. Are these lines parallel? Well, you look at the m value here. Technically there's a 1, we just haven't written it. Well, 1 and 2, 1 does not equal 2, so not parallel. Okay, whereas if I gave you something like this, y equals negative 2x plus 4, y equals negative 2x minus 17. Again, you look at the m value, negative 2 equals negative 2, therefore parallel. Alright, so that's parallel lines. Okay, much more straightforward. So then let's talk about perpendicular. Perpendicular lines. So if two lines are perpendicular, that means that they form 90-degree angles. So these two lines here, they are perpendicular because these are all 90-degree angles. Okay? Let's say a line like this, not perpendicular, because you've got an angle greater than 90 and an angle less than 90 here. Right? This line, if we say, right, we've got 90-degree angles, so those are perpendicular. Now the way that we identify these perpendicular lines, okay, two lines are perpendicular. I'm just going to use this symbol, perpendicular, if gradients are, and here's our special word here, negative reciprocals. What does that mean? Negative reciprocals. I should put an S there. Okay. What does this mean? Well, if I gave you a fraction like 1/2, and I asked, what's the reciprocal of 1/2? Well, the reciprocal, you just flip it. So the reciprocal is 2 over 1, or just 2. The negative reciprocal would be -2. Okay, so maybe just pause the video and maybe go over that again, or work that out for yourself a little bit. Let's look at an example. If I gave you this this line, y equals 3 over 2x plus 5, and I asked you find a line perpendicular to this one. Okay, this is just my perpendicular symbol. Or if I said give an equation of a line perpendicular to this one. Well, all we have to do is write something y equals mx plus c. That's all we've got to write, so c can be anything, but m cannot be anything. We have to take the negative reciprocal of this gradient here. So 3 over 2, the reciprocal is 2 over 3, which means the negative reciprocal is just going to be -2 over 3. So now I can create any line, I can write the equation of any line so long as it has that gradient. Plus 900, let's say. Okay, so this line here is going to be perpendicular to this line here because the gradients are negative reciprocals. Okay? I hope this has helped us. I'm going to post another video showing how to rearrange this equation when it's not nicely put into this form. Okay?